Hello, folks. So here we are. Those few of you who are watching this, this is our test prep review practice video. So what I'm going to do is I'm going to go over the practice test that I'm giving you in class. It's also available on Schoology. And I'm going to discuss with you and tell you what the answers are. My suggestion, go to Schoology first. Get the test, write down your answers, whether you do it on your copy like Kami or something like that, go for it. Then come back here and we'll go over each and every single one of them. So without further ado, if you need to, pause the video. I'll be right here, especially since I can't leave. As you can tell, they keep us here all the time. All right. Let's get started, though. Now, I deleted the first 5 questions off this test. Don't worry about it. It's a format of question that is not used anymore. We will worry about practicing that format when we get a little bit further in the year. So, if you take a look, we're starting at number 6. Which of the following is not a goal of science? Now, remember, science is designed specifically to explain events in nature, to make useful predictions, and to understand and investigate the natural world. It is not designed for C, to use data to support a particular view or idea. That is not science purpose. Number 7. Which of the following is the smallest level of classification? Smallest. So we start at the biggest up top, and then it gets smaller and smaller and smaller, more pointed towards the bottom. Well, if you remember, kingdom's at the top, phylum's right below it. Then a little bit later is class, but down near the bottom, the smallest one is D, the species. Remember, King Philip came over for grape soda. Number 8, if we record the mass that a goldfish eats in a week, we are collecting C, the data. We're collecting data. Number 9, if you state, I add weight to the plane, then it will not fly as far. This statement is a B, hypothesis, if then. And it's worth noting we are clearly saying what we are changing and what we expect to happen. You must have both of those specific for it to be a good hypothesis. Number 10, Linnaeus started our modern style of classification. What method did he use to classify organisms? Well, if we remember, Linnaeus' system was not perfect because he based it off A, their appearance and behavior. He didn't have any other data. So he just based off what things looked like. And we know we cannot judge books by their cover. Number 11, in science, a hypothesis is only useful if C, it can be tested. A and B, it doesn't matter whether it's right or wrong. That's unimportant. The important thing is, can we test it? Can we find out if it's right or wrong? That's what we need to know. Number 12, a controlled experiment, which is just an experiment, allows a scientist to isolate and test one variable. If you test more than one, you can't tell which one gave you the result that you got. If we change the weight of the plane and the shape of the plane and it flies better, we don't know which one was responsible. Did the weight help more? Or did the shape change help more? So we want all experiments to be limited down to a single, just one variable. Number 13, which of the following is not part of doing science? We will always observe in science. We will always experiment in science. We will always make our hypothesis. We will not generalize. So B, generalizing is not part of science. 14, a theory is a statement of scientific facts supported by D, thousands of experiments, all proving it correct. Number 15, which of the following is a hypothesis? So if we add mass, something will happen. No. First part's good. But the second part isn't clear. What will happen? What do you expect to happen? You got to be specific. Let's look at B. If we change the shape of the wing, then it will fly further. Yeah, that's good. B is a good hypothesis. 15, the answer is B. 16, biology is the study of. Now, people get caught here. Remember, biology, life, ology, study of. So it's a study of life. Which one of these is the best study of life? It's not A, because land, water, and earth are not alive. It can't be C, because plants and animals only doesn't account for things like bacteria or fungus. So the best answer here is not just D either, because the environment's only one aspect. It is B, the living world. Biology is the study of the living world. The lights are going to turn off in a moment. All right, 17. Which of the following is not a characteristic of life? Living things respond? Yes, they do. Do they maintain a stable internal? Yes, they do. Are they made of cells? Yes, they are. Are they capable of moving quickly? No. 17, the answer, which one is not a characteristic of life? That's D, because moving quickly is not required. 18, which of the following best explains why bears hibernate during cold months? Because they, D, are responding to their environment. 19, a pack of wolves need many things to survive. Which of the following is required? Is it required that every member reproduces? No. Is it required that all wolves live to old age? There goes the lights. No. Is it required that all the wolves must live in the same place? No. It's useful, but no. Is it that D, some of the wolves must reproduce? Yes. As a species, they must reproduce, not as individuals. Number 20, what is the name of the process that allows us to maintain a stable internal environment? B, homeostasis. Hopefully you remember that one. 21, the metric system, the common unit of volume is B, the liter. 22, maintaining homeostasis, hey, there's that word, is related to which characteristic of life? So which one is it related to? Which one of these other ones do we need to do in order to maintain homeostasis? Do we need to obtain materials and energy to maintain homeostasis? Respond to our environment to maintain homeostasis? Change over time to maintain homeostasis? Or be based on a genetic code to maintain homeostasis? The best answer here is A. We must obtain and use materials and energy in order to keep ourselves in that living range. Ooh, 23. This one is not one that you are going to see on the test. 13 centimeters is equal to how many millimeters? Well, it would be effectively like a jump over. So that would be 130 millimeters, because millimeters are smaller, so the number has to go up. 24, what is the purpose of a biological key? We've used them a ton. You're going to in half a page. The idea would be to D, identify an organism based off characteristics. Characteristics and behavior, if we have behavior. 25, which of the following is not in the metric system? That is letter D. Fahrenheit is not part of the metric system. 26, which of the following is not part of the microscope? Also, this one's a little bit outdated because we don't talk about the coarse adjustment and the stage anymore. Those are both parts of the microscope, but a beaker is not part of the microscope. 27, what is the definition of a control? So in every experiment, you want to test one variable, and you always need a control. Remember, the control is the natural. It is the normal. We want to find out what happens without any changes, just whatever the normal state would be. So that's A, an unchanged test to simulate natural conditions. 28, which of the following is not part of the scientific method? Well, if you look through there, it's D. Design an experiment to test multiple hypotheses. We don't do that. We test one hypothesis. 29. Which of the following is the correct order for classification? I gave you a mnemonic. King Philip came over for grape soda. So if you remember that and you take a look, it's got to be C. It's the only one that has the letters in the right order. Number 30. What is the definition of science? B. To answer questions about the natural world. All right, here is our biological key. I want you to identify each one of these birds. So if you haven't, pause the video, go through and try to figure out which one's which, and then unpause and I'll give you the answers. All right, 31, bird W is Geospiza. 32, bird X is Platyspiza. 33, bird Z is Camarhicus. 34, bird Y is Cirthidae. How do we know? Well, Cirthidae is the only one with a long, slender beak, so that's right there. All the other ones come down here. Geospiza, our first one, has that flat, straight part on the lower beak. And then when we get down to our last two, it's all about the curve in their beak. One of them has the curve, Camarhicus. The other one does not. 35, we collect pigeons. We split them into two groups. One group gets a diet purely of popcorn. The second group is fed their natural food, seeds, fruit, bugs, etc. After 2 weeks, the popcorn group is having difficulty flying and is getting weak and sick. What is a possible hypothesis for this experiment? Well, you have a lot of different choices, but looking at this, clearly the difference is food, and the result is their health or illness. So you would want a hypothesis that says something like, if we feed pigeons popcorn, then they will get sick. Or if we feed pigeons their natural food, then they will be healthy. Or if we feed pigeons popcorn, then they will be healthy. It was wrong, but it's testable, so it's okay. Kind of. Or if we feed pigeons their natural food, then they will get sick. Also wrong, but testable, and that's the important part. 36. An unknown organism moves along the ground, absorbing nutrients in other animals. After a few months, it's grown large, it splits in half, and each half wanders away. Is this sexual or asexual reproduction? Asexual. One parent. 37. You notice that mice will generally run away from cats, but not dogs. Please form a hypothesis to test, and then explain how you design your experiment to test it. Well, hypothesis must be specific. If a mouse sees a dog, then it will not be afraid. Or if a mouse sees a cat, then it will be afraid. Or if a mouse sees a dog, then it will be afraid. Or if a mouse sees a cat, then it will not be afraid, right? All of those are specific. What we're doing, what we expect to happen, those two parts. Now, how would we design the experiment? Get two groups of mice. Half of them see a cat, half of them see a dog. We measure the response. 38, name 4 of the 8 characteristics of life. Cells. DNA, responds to their environment, reproduces, grows and develops, needs materials and energy, evolves, and maintains homeostasis, the balanced internal environment. Those are the 8. Make sure you know 4. 39, below is an image of a chamber designed for a particular experiment. The organisms would be released into this little middle part, right here, the center bridge, and then 2 different food sources would be placed in either side of the round chambers. Test A, we start with mice. They move towards the sides with cheese and avoid the side with celery. Does this prove that cheese is their favorite food in the world? No. It proves they like cheese more than celery. It does not prove that's their favorite in the world. Letter B, how could you improve this experiment to better determine how much mice like the cheese? Well, we should run it with different foods, other foods that they also like, and see which one do they favor. Maybe run it with something like peanut butter or cookies or whatever. You get the idea. All right, then a graphing question. Now, this one I can't really show you here, but along your x-axis, you should have your days because that is in your left. Make sure that you label it as days. And I would spread them out by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We only need to go to 10, so that's easy. Growth should go on your y-axis. I would label this by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, we can't go by ones. Look, we have to go to 15 and it won't fit. Twos, 2, 4, 6, 8, 10, 12, 14, 16. No problem. And then at our line on day 1, 2 centimeters tall. Bloop. On day 3, which is going to come between 2 and 3, or no, on 3. No, sorry, getting confused. It should be up to 4. You get the idea. Line graph, very simple. Do not connect it to 0 unless that's one of your data points. All right, now this last one, this is reading a graph, and I picked a graph that came right out of the Regents. That's why the copy has a little bit of blur to it. All right, it says, as the depth of the ocean increases, the amount of light that penetrates to that depth decreases. At 200 meters, little, if any, light is present. The graph below illustrates the population size for 4 different species at different water depths. So if you take a look, the water depth increases as we go over to the right. The population size increases as we move up. Species A is the solid line. Starts down here, moves up. Species B is the dotted line, starts high, goes low. Species C is the dashed line, stays pretty much the same. Species D is the solid dark line, and that one starts here, gets better, and then kind of drops down again. Which species has the greatest population in shallow water? Shallow would be on the left side over here. So that would be species B, because their dot is the highest on population at the shallow side. Which species has the most constant population at all depths? So no matter where you are, its population is mostly the same. Species C, because it stays right near this line and never really changes, whether you're shallow or deep. Which species would you expect to find more of in the deep ocean? So now you want to come over to the deepest part, which would be all the way over here. You want to look up who has the greatest population in the deep side. That's species A, way up there. And which species has the same population in shallow and in deep? So it would be on the far left and the far right. And that is species D, because you can see these two are equal to each other. So that's just a little bit of practice reading graphs. So I hope this helps. Tomorrow is our test. I will have a red copy where I kind of do the same thing, uploaded and ready for you tomorrow. Ladies and gentlemen, have a great day. I hope this has helped, and I will see you tomorrow.